Sorry for the. Okay, so my board was hanging earlier, so I'm trying to see if I can. Okay, it's working now. So sorry. Sorry. 1 minute. I'm trying to get my board up. Okay, so in today's class, we please if you can hear me, just say something on the chat box. Right? If you can actually hear me, please say something on the chat box. Someone said data consumption. So sorry, Jerry. So sorry. Just want to try this out. I've not really perfected this particular stuff, but then I'll try as much as I can. So let me switch and see if I can capture my screen, because the first time it was giving me issues. Hopefully to work this time around. Oh, thank God, it's working. All right, so we are good to go. Let me import the past question. Remember, today's class we want to talk about past question, okay? So hopefully be able to achieve something today. Okay, so just 1 minute. We are good. Okay, so in the board. All right, so I have my past question here. It has come up finally. All right, so I'll try as much as I can to. Okay, so now what exactly do we want to do today? Like I told us, we want to treat past questions. I want to treat past questions. Okay, so this is actually the most recent the most recent past question. So that's basically what we want to treat today. Right, this is the most recent. Okay, now if you look at the first question, right, the first question, question number one. If you look at the first question, question number one, they said, okay, let's get it by the side. Please pay attention, right? We're going to learn 2 times today. Maybe after now, you can still do a little. Now look at the first question. It said the heat capacity of oxygen at constant pressure of 3.56 atm is found to be. Now, remember, heat capacity at constant pressure, right? Let me, remind us a bit. If you could remember, heat capacity at constant pressure is always, we have Cp equals to 28.86 joules per Kelvin per mole. Now, this is actually the Cp. That's for the first question, right? Now, they said the change in enthalpy, like delta H, is what we are asked to find. They said the change in enthalpy of 134.4 grams of this gas when heated. Now, the T1 is actually 210 Kelvin, right? And then we have T2 to be 292 Kelvin. Now the mass is 134.4 grams. Now bear in mind that they said oxygen. Now the molar mass of oxygen is 32 grams per mole. Okay. Now, you may want to ask yourself, how do we actually solve this question? Okay. Let's zoom in. You might want to ask yourself, how do we solve this question? Now, if you could remember, there is a formula. There is a formula that says, look at the left-hand side, delta H equals to NCP delta T, right? So that is a formula we're going to use to solve that first question. But if you notice, they gave us CP in that question, which is what we have here. They gave us T1. Now, this delta T, this formula can be written as CP T2 minus T1. Now, this T1 is this 210 is a T1, the 292 is a T2, all right? Now, the CP is given to us. If you noticed, they did not give us N. They did not give us number of moles. But then, if you look at this guy very well, they gave us mass and they gave us molar mass. So therefore, my N, which is number of moles, will be 134.4 divided by 32. If you press your calculator, this will give us 4.2 moles. All right, that will give us 4.2 moles. So you can now come down here and say, okay, so therefore, my delta H equals to NCP delta T. Now, my N here is 4.2 times my CP is 28.86 times this becomes T2 is 292. Okay, so let me push this by the left so that I can have enough space to write this. Sorry. So this will be very fast. And once I'm done, some questions does not really require calculation. Some of them is just answering. Okay, so I'm just trying to explain this. Now, this becomes equals to our N is 4.2 times our CP based on this. Please look up. Based on this guy, CP is 28.86. We have 28. Some of us, I believe you've seen the concept to solve this already, all right? So this is 292 minus 210. If you solve this, evaluate everything here, your delta H now becomes equals to 9939.4 joules. That is the answer to that question. Okay? So please, if you have any question, please ask. So for the first question, this is how we solve the first question, right? Now, this is how we solve the first question. Now, let me zoom in my screen again. Please, I believe everyone here should have the past question. Okay? So if I'm to zoom in my screen, now this is what I have. Now, this is the answer to that question, everybody. Okay? This is the answer to that question. All right, so let's look at the next question. Please, if you don't understand, just type it on the comment box. I'm using my phone, right? You might look at me checking out my, looking down. I'm using my phone, right? I'm streaming with my laptop, so I'm using my phone to actually check for questions, right? I'm sharing my screen, so I may not be able to see your questions if I'm using my laptop. So I'm going to be, intermittently checking through my phones. If you have any question, please drop it here, okay? All right, thank you very much. All right. So let's look at the next. Every time you get a call person, I don't get time for these things. I did busy now. All right, so let's look at this question here. Now, question number 2 says 12 grams. Please look at this question very well. All right. Am I actually, at the end of the day, I might just shrink it out of the screen so that I have enough space to solve. Now, the question says 12 grams of aluminum. Now, look at it. Now, CP, this is heat capacity. 0.215 calorie per degree Celsius per gram. All right, at 70 degrees Celsius, is placed in a beaker that contains 35 grams of water at 30 degrees Celsius. The temperature at which the aluminum in water mixture comes to thermal equilibrium is dash. Now, this particular question is, if you could remember, in bomb calorimeter, these particular questions come from bomb calorimeter, where you have mass of heat lost by a metal is equal to heat gained by water. So it's just like you drop a hot nail inside a cup of water. Now, the cup of water initially was cold and the nail was hot, okay? Now, heat temperature system. So if you drop the nail inside a cup of water, you're going to realize that the nail is going to lose some heat and the water is going to gain some heat, right? At a particular point, both the nail and the water will have the same temperature. So that's basically what they're asking us to solve here, okay? Now, let me shrink the screen. I believe you've seen the question for those persons that may want to write. If you have your past question, is okay. But if I'm to shrink this screen, okay, so that I'll have enough space. I want to shrink the screen. I've cleared it. Please look up. I believe you've gotten the question already. Please let me zoom in the question again. Now, question number 2. Please look at question number 2, right? I've zoomed it in again. I'm using Johnson past question, right? I don't have time to solve here, but I'm resolving all of them. So if you look at question number 2, it's actually appearing on the screen. The question says 12 grams of aluminum, right, at 70 degrees Celsius is placed in a beaker that contains 35 of water at 30 degrees Celsius. The temperature at which the aluminum in water mixture comes to thermal equilibrium is dash. Is dash. Now, I'll zoom it in again for the avoidance of doubt. Okay, so I'm going to shrink this guy once again. But before I shrink this guy, I would like to point out something here. Please look up. Before I shrink back this guy, I would like to point out something here. Now, if you look at this question, right? This value here is actually the heat capacity, the specific heat capacity of aluminum. And they gave us here, the past question is not showing very well. If you look at my right-hand side, this side I circled, they gave us heat capacity of water, just in case in exams you're looking for the value. They gave us the heat capacity of water, both in calorie and in joules. All right, let me show us again. Okay, someone said I should drop it on the group. Okay, please. I think as I'm teaching, I'll be dropping this in on the group chat. But then the issue right now is that I have 3 group chats. I don't know which of them to drop it. So let me drop the question on the group chat so that we can all. Please, I'll do it later, right? I will do it later because it's going to come. It's going to be stressing me now. Okay, yeah, just give me 1 minute. Let me drop it on the chat. Stressing through because of the love I have for you guys. Please 1 minute. Let me drop it on the chat. I want everybody to have this question, right? I'm doing this so that everybody will have it. I want everybody to have this question so that I won't be zooming in the screen it out. Okay, I'll drop it on the group chat now. Okay. So make sure once I say question number 2, you already know the equation I'm referring to. I'll drop it. So let's go back to our solving. Let's go back to our solving. Now let's get this back to our solving. Please look up. Now, what I would like us to understand here is that if you could remember this formula, is what we call heat loss by aluminum equals to heat gained by water of aluminum, change in temperature of aluminum equals to mass of water, specific capacity of water, and change in temperature of water. Now, please, if you look at the question, let me share the question. I just sent it to one group, so I'm about to share it to all the groups now. Okay, I've sent it. If you look at the question there, they gave us mass of aluminum. Please, I'm going to be writing this out. Mass of aluminum is 12 grams. They gave us 12 grams as mass of aluminum times this heat capacity of aluminum was given to us in that question as well in calories per degrees. So this is 0.215, okay, times. Now this bracket is T2 minus T1. But if you look at that question very well, we were told that aluminum at 70 degrees Celsius, meaning that 70 degrees is the initial temperature of the aluminum before it was dropped into water. Okay? Now, the final temperature of the aluminum would be the temperature of the water after the aluminum have stayed inside water for some minutes. Because if you drop something that is very, very hot, take for example, you drop a spoon that is very hot inside a bucket of water, you realize that after some seconds or after some minutes, the temperature of the spoon would be the same as that of the water. All right. So the final temperature is what we are asked to find. So that is my T2. Okay. So this, I'll write this to be 12 grams times 0.215 times T2 minus 70 degrees. Now, that of water, the mass of water, they gave us mass of water to be 35. Now, the specific capacity of water. Class, look at this very well. Let me show something. They gave us the value of this guy. Let me show so that. Now, look at this. They gave us the value of this, that of water to be 1 calories. This is a specific capacity of water, the one we are going to use. Because aluminum, they give us in calories. So I'm going to use calorie as well for that of water. So I'm going to use 1 calorie per degree Celsius per grams. Okay, so let's go back to that calculation. I believe some of us, with this formula, you already know how to solve this question. So that is it. Some of us are just looking for, a guidance, which I'm very sure some of us already know how to solve this. So this becomes equals to times 1 times. Now, the temperature of water, this is also T2 minus T1. The temperature of water, initial temperature of water was 30 degrees Celsius. If you look at the equation very well, so this becomes 35 times T2 minus 30. Okay? If you multiply 12 times this is where I'll take some time because this calculation is going to take our time. I didn't want to solve it and post it. I wanted us to do it live at once. If you punch your calculator, this is going to give me, I think I already pressed this somewhere. This will give me 1 minute. So this is 12 times 0.215. So we have here to be 2.58. T2 minus 70. So this becomes equals to 35 T2 minus 30. All right. So if you open this bracket, 2.58 times T2 becomes 2.58 T2 minus times 70. This becomes 180.6 equals to 35 T2 minus 35 times 30. This is 1050. 35 times 30. Okay, so of course you collect like terms, right? Anyhow you want to do it. I would say this comes over to this other side, and this comes over to this other side. So how do we go about it? Please. So this is times this, times 70, we have this. So if you collect like term, this would be 2.58 T2 minus 35 T2 equals to minus 1050 plus 10. Please, let's do it the other way around. I don't want to start wasting spaces. So let's keep this guy. If you bring 35 over to this side, 35 T2 minus this one here, 2.58 T2 equals to, you now take this one over to this other side. We now have minus 1050 plus 180.6. Please, if you do this, 35, since they are the same, you collect like terms. So say 35 minus 2.5. Now this becomes 35 minus 2.58. This becomes 32.42 T2 equals to, this is minus. Okay. Yeah, this is supposed to be minus. Sorry, it's supposed to be minus. And because if this one should come over to this side, it will be minus. Please take notes. This 35, when it crosses over to this side, it becomes minus. When this one crosses over to this side, it becomes plus. So we have minus 1050. Please, your calculator should be of help here. Minus 180.6. And this becomes 869.4. minus. So if you make T2 subject of the formula, this becomes 869.4 over 32.42. So the value here is 26.8 degrees Celsius. Okay, so that's for question number 2. Why you guys complain of data? I don't understand you guys. So. Now they talk like same here, they use water, they do all these things. It's not the same data I'm using. Okay, so let's look at question 14, question number 3. You see, when I say, this question number 3, look up. The states, please, the states in which two bodies in physical contact with each other have reached identical temperature. The answer to that question is thermal equilibrium. thermal equilibrium. So this is actually thermal equilibrium. All right, now number 4 says, a thermodynamic system which allows the movement of mass and energy from the system to the surrounding is referred to as, if you can remember types of system in thermodynamics, we have the open system, we have the closed system, and we have the isolated, right? The system that allows the, exchange of both mass and energy across a boundary is actually an open system. So this number 5 is an open system. Open system. No, number 4 is an open system. Number 5, they said dash point is where three-phase equilibrium boundaries meet. Now we call it triple point. That number 5 is triple point. Triple point is a point where the three-phase equilibrium boundaries meet in a phase equilibrium for a pure substance. All right, now number 6 says the relationship between heat capacity at constant pressure and volume for 1 mole of a gas. Of course, if you can remember this formula, Cp plus Cv equals to Nr. For 1 mole of gas, this N becomes equals to 1. So you're not going to put N here again. If you put N here, they will mark you wrong because they stated for 1 mole. This N is for N mole other than 1. So take note of that. It's a very logical question. So the answer to this guy will not have the N. Okay, so it's just going to be Cp plus Cv equals to R. Okay. Now, please look at this number. Let's clear my screen. Look at this number 5 question. This number 5 question, please, I'm not going to solve this. I already solved it in my material, so I'm just going to go and preview my material for you guys to see how it was solved, right? So that they said, if 5 mole of an ideal gas, please listen very carefully. What you need here is just to understand the concept of this guy. Please hold on. What you need here is to understand the concept of this question, right? They said, I'm not, to save time, I'm just going to my material. So I'm just going to go and preview my material for us to actually check it out, okay? Even number 8 as well. Now, mole of an ideal gas were expanded reversibly and adiabatically from an initial pressure of 20 atm and temperature of 300 Kelvin. And after expansion, the temperature was found to be 180. What is a final pressure? Now, this particular question falls under reversible adiabatic expansion. Remember, reversible adiabatic expansion has 3 formulas. The one that relates pressure and volume, the one that relates pressure and temperature, and the one that relates temperature and volume. Let me quickly take us to my material where I explain all of those stuff. Okay. So just give me. Now look at this. This is my material, CHM240 material. Okay. Now let me take us back to that immediately so that you understand how we got that. Now look at this. This is adiabatic process. Let's make it single size. Now this is adiabatic process. Reversible adiabatic process. Now class, please look up. The first formula here, right? I can't really write. I think I should have this in my board. Hold on. Let me check this in my board. I should have it in my board. Okay, I have it. So let me quickly check let me check page what? That was page 22. So let's check page 22 in my board. So we have this to be page 22. Okay, class, look up. Now we have this already, right? Now, this adiabatic process. Let me explain something here so that you understand what I mean here. Now, this is a first formula. The first formula is actually this guy for adiabatic reversible expansion. Sorry, I believe you know that formula already. Where you have the first one is between that relates temperature and volume. You have T1, V1, gamma minus 1 equals to T2, V2, gamma minus 1. Right? That is the first formula. This one relates temperature and temperature and volume. Now we also have the one that relates pressure and volume. Now look at this guy. The one that relates pressure and volume is this. Okay, so we have P1. This one relates pressure and volume. We have P1, V1, gamma equals to P2, V2, gamma. Now, when do I make use of this formula? When they give you a question and they say something expanded reversibly and adiabatically. It's just like giving you a question under gas law. You know when to use Boyle's law, you know when to use Charles' law, depending on the parameters that is given to you. All right. Now, this is a second formula. Now, the last one relates temperature and pressure. Now, this is the last one here. This is the last one. P1, gamma minus 1, T2, gamma. Let's expand this. This is actually where we are going to solve the question because this is where the question is given to us. So now look at this. This is a formula. This formula relates pressure and temperature. P1, gamma, T2, gamma minus 1 equals to P2, gamma minus 1. Sorry, this is meant to be gamma minus 1. Please. I'm trying to be fast so that a lot of persons are complaining of data. So let's achieve something. P1 is gamma minus 1. T2 gamma equals to P2 gamma minus 1. T1 gamma. Now, why are we using this particular guy for that question? Now, look, this is a question I have here, very similar question. The only difference here is that in the one they gave you guys in exams, they said 5 mole, but here they said 3 moles. Other than that, every other thing is the same. And also, the pressure they gave to you guys is 20, while here is 18. Okay, so I'm going to solve this particular question. If you understand how I'm going to solve this, it's the same thing like what they gave you guys previously. It's the same thing, no difference. So I want to solve this so that you understand how to solve this. Now, first and foremost, they said something expanded reversibly and adiabatically from initial pressure. Now, they gave me pressure. If you notice, I'm checking out what is related. They gave me pressure, P1, to be 70 Kelvin. They said after expansion, it was found to be pressure. Let me confirm to be sure that was the same question they asked us. Exactly. That was the same question they asked us. Please look up. I'm just going to be reviewing my screen so that you see how I solve this. Okay? There's no need of me resolving it. If you look at this, P1. Now look up. If you look at that question here, right? I need to solve for my gamma. What is gamma? Gamma is what we call heat capacity ratio. Gamma is called heat capacity ratio. The question here, they did not give us gamma. But if you look at this formula, there is gamma here. You must use gamma. And what is gamma? Gamma is what we call specific heat capacity ratio, right? It is gotten by saying Cp, heat capacity at constant pressure, by Cv, heat capacity at constant volume, right? Now, in the question, please look up. Let's look at the question again. In the question, they'll give you, they gave us Cv to be 37. Please just watch out and see how I want to get my gamma. I want to get gamma now. They gave me Cv to be equal to this. They did not give me CP, but I know that CP plus CV is equals to NR. Please watch what I'm doing here. I'm only guiding us on how to get this correctly. This stuff, this guy, they said N mole. Just listen. The number of mole they gave us in that question was 5. So for me to get my CV, I'll say CP equals to NR minus CV. Is this meant to be, oh, sorry, this is supposed to be minus. This is supposed to be minus, sorry. The relationship between CP and CV is supposed to be CP minus CV equals to NR, please, not plus. Please refer back to question number, I think question number 3, when I said it's plus, it's minus, not plus, please, it's minus. So the relationship between this guy is minus here. I'm on this classes, so it's taking my energy, so a lot. So we have CP equals to NR plus CV. Our N here is 5 times 8.314. Okay. Now we have plus 37.28. Let me check. I don't have calculator here. So this becomes 5 times 5 times 8.314 plus 37.28. Now this becomes equals to 78.85. That's my answer. All right. So my gamma now becomes CP over CV. Now 78.85 divided by 37.28. Now divided by 37.28. So my gamma is 2.11. Okay, 2.11. Now here is 1.22 because the values are not the same. Now once you've gotten your gamma, is I'll be cleaning. You've seen how we got our gamma. First, they'll give you one of this CV. From this CV, you can get your CP. Once you're done getting your CP, you now say gamma equals to CP all over CV to get your gamma, right? Once you've gotten your gamma, you now say, so therefore, gamma minus 1 equals to 2.11 minus 1. That is 1.11. So that is the value for gamma. All right? That's the value for gamma. So please write so I can clean this off. All right. So moving forward, so I want to clean this off. All right. So let's look at the next page. Now this is the next page. Class, watch out and see what we are doing here. Now from that formula I gave us previously, right? From the formula that relates pressure and temperature, I gave us a formula, which was, if you can remember the formula, it was P2 gamma minus 1 T1, or vice versa. I can do it vice versa. Then we have P1 gamma minus 1 T2 gamma. This is a formula that relates temperature and pressure. Now you're asked for the final pressure. This is the final pressure. So this is P2 gamma minus 1 is 1.11 times temperature T1. From the question, if you could remember, our T1, they gave us T1 to be 180 degrees. So this is 180 raised to the power of this. Please, after you must have gotten this from your calculator, I want to show something how to get your P2. Let's assume your P2 was equals to 5 points. Let's say 5. Please, I'm just assuming this is not the correct value. I don't really have calculator. When you press all of this, whatever your P2 gives to you, how do I eliminate this 1.11 as a power? Class, you're going to raise this guy, raise it by the reciprocal of this. This is what I mean. P2, 1.11 equals to 5 over 6. Now, why did I raise it by the reciprocal of it? So that this can cancel this. Once this cancels this, we're not going to be left with P2 equals to 5.6, 1 over 1.11. And of course, you can get this from your calculator. And that becomes your final answer. Please take note of this. This formula we used previously, where I said how to get your CP minus CV equals to NR. Now, you can only do this when they did not give us CP in the question. If they give you CP in that question, just use it directly, okay? All right, so let's, please, if you have any question, ask. Any question? I mean, I know they ask question for this class. All right, so let's look at the next question, class. Let's look at the next question. All right. Let's go back to my, sorry. We're making progress little by little. Now let's look at the next question. Question number 8. Question number 8 says, please, if you're watching us for the very first time, and then please help us hit the subscribe button. Thank you very much. All right, let it be that this is actually what we benefiting from the class. Help us to subscribe. Okay, just help us to hit the subscribe button. I'm actually streaming both my laptop and my phone. For those people that are complaining of data, you don't really know how much data I'm spending because my laptop consumes so much data than phone. All right, but that's by the way. All I just want you guys to at least have a very wonderful exams. All right. Now look at this. Question number 8 says the rate of, let me expand this better. Question number 8 says the rate of reaction BHCl plus this, giving us this. I think this should be, I don't know what they did here, but I think this should be HCl. Okay, P is a coefficient. Now, let's reduce this stuff. I taught us this on, I think on Saturday. Yeah, I treated this on Saturday, which I'm going to upload. I've been trying to upload these things, but my network has been bad before now. I just had to put my router somewhere else. Now, this is a question. Please look up. The question says HCl plus half O2, you have R H2O plus SCl2. Now this is it. Now out of this four reaction, we have four reactants here. Please, it's none of my business for me to start looking at what is here. All right. What I'm asked to balance is what they asked me to find the value of R, S, and P. Out of the four species in this reaction, the reactants we have HCl and O2, we have water and Cl2. Okay. Now they gave us the coefficient of oxygen only. And we are asked to find that of P, that of R, and that of this. Okay, now, but for us to solve this, I taught us something on Saturday. Now, if you look at this, they gave us the rate of HCl to be equals to 0.04 molar. They gave us the rate of water to be equals to 0.06 molar. They gave us the rate of Cl2 to be equals to 0.02 molar. Please, I'm going to solve just one of them, and then I'll actually guide us. Perhaps you use the knowledge from here to solve the rest. 1, 2, 3. So they gave us the three values of this. All right. Now they're supposed to give us that of oxygen. I think these people are they're supposed to give us that of oxygen. There's a mistake here. Please, there's a mistake in this question. We have four reactants, four species, two reactants and two products. All right, but what they gave us here is three. It's supposed to be four. So I have HCl here, water here. That means Johnson, when he was retyping this question, or mistakenly omitted the last one. But I think I have questions similar to that. So let me just take us to my material, CHM240 material. Okay, so that I will show us how that question is being solved properly. Just in case of exam. My back is showing me pepper. Kai. I'm so sorry. My material is actually not showing it properly. It's breaking. But let me just show something. Let me manage what I have here and just show something. Please look up. Sorry, I thought my material is actually not showing it properly. Now let me show something. Let's just assume, here, right, that of oxygen, we are just assuming. Let's assume that of oxygen is 0.03 molar. This is what you're going to do. They are asking you to solve for the unknown, this P, R, and S. So first and foremost, you're going to compare HCl with oxygen. Why? Because oxygen has a coefficient. So I'm going to compare the one that the coefficient is known with the one that the coefficient is not known. So I either compare P and this, or this and this. So I'll say, let's start with this guy. This is what I'm going to do. I'll say rates of HCl all over rates of oxygen equals to coefficient of HCl all over coefficient of oxygen. That's how to solve it. So this is the same way you're going to use to solve all of them. Now, what is the rate? What is the rate of HCl? Rate of HCl, they gave us here to be 0.04. Now, what is the rate of oxygen? 0.03. Please remember, I'm just assuming that we are not sure of this, but this is how to solve it. Now, what is the coefficient of oxygen from the question? They give us coefficient of oxygen to be, please let me move this. They gave us coefficient of oxygen in the question. If you look at this guy, now this is a coefficient of oxygen. They give us a coefficient of oxygen to be 1/2 divided, that of HCl is P. Right, so now we want to solve for P. Remember, this 0.03, I just had to put it here. They're supposed to have given to us in the question, but I think when Johnson was retyping this, he mistakenly skipped it. Right? If you check your textbook, I think this question is inside. If you cross multiply, please to save yourself of stress, this half, just put it to be 0.5. Eh? Don't even stress yourself and start doing equation. Just use calculator. Whatever fraction they give to you, convert it to 0.5. If you cross multiply, this is P times 0.04 equals to 0.5 times 0.03. Once you do that, this becomes P equals to 5 times 0.03 all over 0.04. Whatever answer you have becomes your P, right? Please, you have to be active. Remember, tomorrow is exam. So all of this, just pay attention. In case you see questions like this, first they will give you the rate of the four reactants, right? Hello? Ah, wow. Okay. All right. Please let me thank you. Rema called me. Someone called me to inform me that you guys were not seeing my screen. Let me check. Set. Please, can you see my screen now? I've shared back the screen. Please, can you see my screen now? Hello, can you see my screen now? Okay, so let's this guy funny. With these rainbows. He says we just the watch face in face with no fine. Come on, no vex for me. That's all God take rates me. My next life I go fine. But regardless, my wife love me like that, the vibe we bring now. So let's switch back. Okay, God, I beg. Ah, God, oh. Okay, please, I've reshared my screen back again. Please confirm if you can see my screen now. Please confirm if you can see my screen. If you can see my screen, just type one. Please, if you can see my screen, type one. If you can see my screen, please type one. Okay, thank you, thank you. So that means we are good to go. You guys can see my screen. Okay, please, I'm going to retake this question again. Please look at the question clearly. We are making progress. Although it's kind of, stressful, but at least bad as it bad, we are making progress. Please look up. Let me do something now. I really want to share this solution with us, but I think it's proving difficult. So this is what I want to do. I want to screenshot my PDF material and then show us at once. So just give me 1 minute. So let's do this. I want to screenshot this material because if I open it on my board, the equations are not showing. Okay. Okay, I think you guys can just see my screen now. Let me just use it like this. You can see my screen, I guess. Okay, so let me just solve it here. Now the question in that particular question, now look up. Let me see the question again. God, I beg you. Okay, so let's all right, please look up. Yeah, I think I've gotten the question now. Let me zoom in my screen. All right. Now, please look up. Look at this question here. I just want to use this question to explain that stuff. Look at this question, this particular question, right? So that, look at this question. They said, consider the reaction 2Q plus CY, right? Giving us SF plus TT. Now, this Q, this Y, this F, and this T, in exams, they might replace it with a real compound, just like we saw in the previous stuff. Now, out of these four species, C is a coefficient which we do not know. Okay. F is also a coefficient which we do not know. T is also a coefficient which we do not know. So the only coefficient we know here is 2. Right? Now they said the following rates were obtained as the concentration of as the rate of this reaction. The Q, they gave us the rate of the Q to be 0.05. The Y, they gave us the rate of the Y to be 0.150. The F, they gave us the rate to be 0.075. And the T, they gave us the rate to be 0.025. Now look at what I was trying to explain here. I said, now, they are just asking me to solve for my C, my F, my C, my S, and my T, these coefficients. So for me to do this, this is what I'm going to do. Just ignore this other part, ignore this part, let's look at this. I want to solve for C. Like C is actually the coefficient for Y on the reactant side. So I'm going to compare Y and Q. Why? Because Q has a known coefficient, Y do not have a known coefficient. But Q and Y have a rate. So I will say rate of Y, which is Ry, all over rate of Q, which is Rq, equals to coefficient of Y, all over coefficient of Q. Now the rate of Y, they gave us the rate of Y to be 0.150. I'll come here and put rate of Y. They gave me the rate of Q to be 0.05. I'll put it here. Now, coefficient of Y is what I'm asked to find, which is my C. Now, coefficient of Q is 2. I put this. When I solve for my C, C becomes equals to 6. Now, if I want to solve for my S, now S has F as a product. So I'm going to compare F. Please just follow my mouse. Just look at this F, this reaction. I'm going to compare this F with any one of these. I now know the value of C to be equals to 6. So I can compare this S with this guy, or I might still choose to use what they gave to me from the question onset. So I'm going to compare F and Q, right? I'm going to compare F and Q. When I do that, All right, now look at this. Sorry, my this thing is giving me issues. Please, for the S, look up. Now look at this guy. Look at the top left corner. You can see for the F, I'll say relate RF and RQ, right? So I'll now say the rate of F, which is RF, the rate of Q, which is RQ, equals to coefficient of F all over coefficient of Q. Now you realize that the coefficient of F is S, which I'm asked to find. All right, coefficient of Q is 2, which was given in the question. The rate of F was given to us in the question. The rate of Q was given to us as well. So when you cross multiply, S becomes equals to 3. So that for that particular question that they gave last year, they gave the question last year, they gave it to them again 2 years ago. So I think it's more like a consistent question. Unfortunately, we lost the chemistry thermodynamics lecturer, which simply means that other aspect of CHM240 would be more. The thermodynamic aspect may not be much again because the lecturer that is always in charge of that setting of question um, is no longer around. Okay, so the other lecturers might want to set from where they are actually, expertise on. So that is why I'm not taking this chemical kinetics lightly. All right. After this class, I'm going to upload a video like the class we did on Saturday and the one we did yesterday. But the one we did on Saturday will come first. So if you check it out, at least it's going to guide us. So this is how we got for the F. Now let's go back to our past question. Sorry, let's go back to the past question. Let me show something. Now look at this past question here. Now question number 8. Just look at, I think yours is on the screen now. Who is this brain box? Brain box, you the worry you. I am no vex. I don't check my comment section. Okay, someone said, how did you get the one as the C for water? They gave us in the question. Ifebu Chine Melum. Please let me take questions now. Let me check the comment section. Sorry, I was just bent on finishing what I'm doing. So Brainbox first said try to check your comment section. Okay, sir. I'll check my it does the worry for this comment section. I would really like to know who this person actually. I don't know if it's a she or a he. Okay, now Chinemelum said, sir, how do we get to know this the one as the C for the water? Now they gave us in the question. Okay, Chinemelum, look at the screen. Let me show us the one. All right. Now look at this place. Just follow my mouse. This is it. Now it started from here. Now they gave us CP of water in calories. They gave us to be 4.18 in joules. They gave us to be 4.18 in calories. They gave us to be 1. So this is where I got the 1. Okay. Okay. Brainbox said from the given parameters up the past question. Thank you very much. Thank you. Thank you for helping her to answer the question. Thank you. So Ifebu, I think Brainbox has helped you to answer the question. Now, Sadelsi, that number 7, you will help us display it back on the screen. It didn't show very well. Okay, which number 7 is that? Okay, okay, no problem. I think the number 7, don't worry, after this class, I'll snap it and drop on the group chat. I think so that you can just go through it again. Please, if you have any other question, please ask before I proceed. The calculation part is what is taking our time. Once we get to those parts, once we are done with the calculation part, we are good to go. I wish everybody had the past question for themselves. I would just be solving and not be checking the questions. Okay, so can I continue? Please, if I ask question, try and help me and answer. Let me be sure that you guys are following up, right? Like I said, I'm using my phone to check the comment section. I can't use my screen here to check the comments. So let's look at question number 9. Very simple. The principle of dash says that it is impossible for a cyclic process. Please, the answer to that stuff is second law of thermodynamics. That is the principle of second law of thermodynamics, right? Now, this number 10 is the number 10 question. Is actually the formula to solve that number 10 question. Please, I don't really have my calculator, so I'm just going to give us the formula to solve the number 10 question. Number 10 says a thermodynamic efficiency. I think they should have taught you guys this in class, right? Okay, so number 10 says the thermodynamic efficiency of a steam engine operating at a boiler pressure of 1 atm and condenser at 25 degrees Celsius is dash. Now, like, once again, class, this particular question, I don't think this question is complete. The past question, people, I don't know why they keep cutting out question. Efficiency of a steam engine. For you to solve the efficiency of a steam engine, you need two temperatures, the initial and the final, right? The formula to solve for this is always the final temperature minus initial temperature all over the final temperature times 100, right? Take note of what I just said now. But unfortunately, from the question, I did not see the other temperature. So efficiency of a steaming, you can always check your notes. They used to is always T2 minus T1 all over T2 times 100. So from the question, they gave us only one temperature, which practically that will not work, right? So they would have given us two temperatures. So once again, I think the past question, when they were retyping this, they skipped it mistakenly, right? They should just be putting questions like they're not retyping it. I understand they want to avoid people taking their past questions. So that's how to solve for number 10. Now this is T2, right? Convert it to you convert it to Kelvin. Whatever the T2 is, you subtract it from the T1 and divide it by the T2 times 100. That becomes the final answer. Okay. Now, the next one says the entropy change of a large sample of ethanol of alcohol. This particular one, we have solved it in class a couple of times. This under second law of thermodynamics. The entropy change of a large sample of ethanol when 65 joules of heat is removed reversibly, right, is at 5 degrees is dash. Now, for us to solve this question, this is what we're going to do. This is what you're going to do. You're going to say, we're simply going to say, please look up our heat, right, is 65. Now, but since they said was removed, they use the word removed. It's going to be minus 65 because if heat is removed, it's exothermic. Now the temperature here is 5 degrees Celsius, which is 5 plus 273, which is 278 Kelvin. So the temperature, entropy change, formula for entropy is always Q reversible all over T. So this becomes minus 65 joules over 278 Kelvin. So once you do that, the answer becomes 65 divided by 278. So that answer is minus 0.238 joules per Kelvin. So that's the answer for that question number 11. Now question number 12 says, the molar volume of a pure substance in the gas phase has a unit of m cubed per mole. Right? What molar volume is a dash? Please, molar volume is an intensive property. Intensive property. I don't really want to go into details. We have extensive property. We have intensive property. Intensive properties are properties that are independent of the amount of substance. All right. So molar volume is an intensive property. They are independent of the amount of substance that is actually present in the compound or whatsoever. Okay. All right. Now the next question here says, the speed at which oxygen molecule is moving in a room temperature. What is it? The speed at which the average volume, average oxygen molecule is moving in a room at 25 degrees Celsius. Now, please, this question is under transport properties of gases, right? Or distribution of speed of gases. We have three major speed. We have what we call the most probable speed. We have what we call the average speed. And we have what we call root mean square speed, right? So this question here, they said the speed at which the average oxygen molecule is moving in a room at 25 degrees Celsius. Now, I'm going to take us to a page where all the formulas for the different speeds are available. We did this yesterday in class. For those persons that could not join yesterday's class, let me show us this. All right, so let's look at this. Now, these are formulas here. The most probable speed is 1.4 the most probable speed is 1.4 square root of RT all over M. Temperature, R is a constant, this M is a molar mass, right? So they will not give you the molar mass, but they will only tell you the gas in question. Oxygen in the question is a gas, right? So the molar mass of oxygen is 32. How did we get 32? Oxygen has atomic mass of 16. As a molecule, oxygen is always written as O subscript 2 as a molecule. All right, so 16 times 2 is 32. But bear this in mind that this molar mass must always be in kilograms. Right, but let's finish up this. I'll show us that. Now, the mean speed, the average speed, which is what we are going to use to carry out that calculation, is 1.6 square root of RT all over M. Root mean square speed is 1.7 square root of RT all over M. Now, look at this. Look at this question here. There's a question here that they gave. They said the most probable speed and the average speed. Please, speed is same thing as velocity. In case you see velocity, same thing as speed. For nitrogen, now remember, oxygen is O2, nitrogen is N2, right? Yes. I will solve for the molar mass, right? Oxygen is O2, so oxygen is going to be 32 divided by 1,000. I'm using this as a key point. Then we'll go back to the question to resolve that one. So the molar mass of this nitrogen is 8 grams per mole because nitrogen is 14 times 2. But we need to convert the molar mass to kilograms. That is why we divided by 1,000 to now have this. Temperature, we converted it to Kelvin. Now, this is a formula to solve for the average speed. Now, look at this. Now, this is the average speed, 1.6 square root of RT all over M. So if you put your R, 8.314, times your T is 500, your M is 0.028, you multiply it by 1.6. This is what you're going to have as your answer. All right. Now, having seen these formulas, let's quickly go back to our board so that we can solve for that of oxygen. All right. Now, look up. All right. Now, here, they gave us C to be 5. Okay, not that one. Question number 13. They gave us C to be this question here. They gave us C to be 25 degrees Celsius. When you convert it to Kelvin, this is 25 plus 273. This is 298 Kelvin. All right. Now, oxygen has molar mass of 16 times 2, which is 32 grams per mole. But the molar mass needs to be in kilograms per mole. It's a must. So in kilogram per mole, this becomes 32 divided by 1,000, all over 0.032 kg per mole. So this is the molar mass, right? And the temperature is 298 Kelvin. So let's see how to solve for this. I'll now say average speed, which is U average, is 1.6 RT over M. Now this is 1.6, 8.314 times T is 298. All over the molar mass, you write the one in kilograms. Please, you have to press your calculator. Whatever you have as the answer, that becomes the answer. Full stop. Whatever you have as the answer, that becomes the answer. All right. So let's look at question number 14. Let's look at question number 14. Now, quickly look at this. I'm just going to use a shortcut to solve for this. They said the rate of consumption, please make sure you watch the video I'm going to post later today for chemical kinetics. The rate of consumption of O2 in the combustion of butane. Now, this is a reaction. Combustion of butane is C4H10, right? Now, is dash if butane burns at the rate of this per minute. If butane burns at the rate of 3 Okay, so let's look at this. My issue right now is that I don't really know if this past question, they are putting questions correctly. That's just my concern. Now let's do this. Now let's please look up. The reaction combustion of butane is C4, H10, 6.5. Class, look up. This 6.5 is 6 times 2, 12 plus 1 plus 4 CO2. So I think that is it. Now, I want to use short method to do this. I don't want to use the long cut. So in this case, now this is what you're simply going to do. Now, the coefficient of this butane is 1. This one is 13 over 2 is 6.5, right? Now, this the water is 5, but I have no business with this guy because they gave me that they said butane is burning out. They gave me rate of butane, and they asked me to solve for the rate of oxygen. That is what they are asking me to find. So what I'm giving you guys now is a shortcut. We don't want to go into that long method. So just come here. What is the mole ratio of C4? What again? Shit. Why is my screen always cutting out? Eh? Why? I don't know. So let's take this question again. This is not still showing. What's happening now? Okay, so my screen is up now. So sorry, I don't know why it's hanging. This is my very first time of using this pattern of teaching to stream. So I used to use my Zoom. So Zoom is saying I should pay how many dollars. So class, look up. We are in number 14. We're almost done. These other ones is not that tough. I can't just wait to finish. My back is aching me already. So for this one now, they said the rate of consumption, of O2 in the combustion of butane is dash if butane burns at the rate. So what this simply means, first, let's get the reaction. Now this is C4H10 plus this is 6 1 over 2. 6 times 2 is 12 plus 1 is 13. So this guy is going to be 13 over 2 O2, giving us there's meant to be 4 CO2 here plus 5 H2O. Now, remember they gave us the rate of C4H10 to be equal to 3.12. Okay, let me write it here. The rate of C4H10 . They gave us to be 3.12 molar per second. And then you're asked to find the rate of oxygen. That's what the question is all about. Okay. Now, I told us that questions like this, if you look at, they only gave us a space. So you don't waste your time doing this. So just look at the shortcut I'm about to give us here. Okay. Now, I'm asked to find that of oxygen. Question mark. So I'll come here. Oxygen, I put X under the oxygen. And this guy, I put 3.12. So I'll simply say cross multiply. X is equals to 6.5 times 3.12. That is the answer to this question. You don't even need to stress yourself. Don't stress any, don't stress yourself. Just come here, say 6.5 times 3.12. Now this becomes 6.5 times 3.12. The answer becomes 20.28. Class, that's the answer. It means that if this guy is 1 and this one is 6.5, what if this guy increases to 3.12? This guy will now be 20.28. But since the oxygen is on the reactant side, don't forget this. Since oxygen is on the reactant side, because this is more like saying rate of decomposition. So I will now say the rate of oxygen will now be minus 20.28. But looking at the question here, right? You have to put the minus. In as much as they did not give us minus in this in the butane, they did not give us minus in the one of butane. But when you're writing this, I was supposed to have added minus here to show that butane is on the reactant side. So please make sure that your final answer. Hello. How are you? Okay, just give me 1 minute. Let me comment. It's okay. Wait just 1 minute. Let me open the gate. I was having a class. I love you. My screen. Let me just observe it for a moment. Just give me like 5 minutes, please. 5 minutes. Let me open the gate for somebody. Yes, I'll eat. Okay. Please let's. All right. Please can you hear me? I've been trying to talk to you guys. I don't know. Maybe network has been so bad. Okay. So back to what I was saying. Back to what I was saying. I said in case of exams, right? Please use the shortcuts to solve this. Write the reaction C4H10 plus 13 over 2, which is 6.5, right? Now they gave us the rate of C4H10. That's butane to be equal to this. This is the one we are asked to find. So just make X subject of the formula. You cross multiply, X becomes 6.5 times this, which is 20.28. Okay. Now once you've done that, the answer becomes 20.2. But remember that oxygen is on the reactant side, so you must add negative sign. It's a must. Right? It's a must. You must add negative sign. So when you add your negative sign, this guy becomes molar per second. All right, so let's look at the next question. The heat capacity, question number 15. The heat capacity of a certain ideal gas is given as a function of temperature. That's it's given as a function of temperature. Now they gave us Cp. Let me change my marker, please. They gave us Cp equals to 28.1. 3.68 times 10 raised to the power of minus 60. Now, they said the isobaric heat capacity of this gas at 200 degrees Celsius is. Remember that isobaric process is processed at constant pressure. So isobaric is constant pressure. So what they gave us here is already CP at constant pressure. But however, they gave us T that they gave us to be 200 degrees Celsius. I'll convert it to Kelvin. This becomes 473 Kelvin. So anywhere I see T, I'll put 473 and press my calculator. And that is it. Anywhere I see my T, this guy will now be equals to 28.14 plus 3.68 times 10 raised to the power of minus 6T. So anyway, 3.68. Anywhere I see this, I'll put 473. Please, you press your evaluate that. Okay, so let's look at the next question. So if you press your calculator, that's how to get the answer for that question. Please, this number 16. Number 16 says, non-integral stoichiometric coefficients are sometimes used to balance, please, the answer is chemical equations or chemical reactions, chemical equations. Non-integral simply means something that are in a fraction form, like 1 over 2, 2 over 3, 4 over 5. Those are what we refer to as non-integral. Okay, so they are all used, non-integral stoichiometric coefficients are sometimes used to balance chemical equations. All right, now number 17 says, it's like, All right. Please, question number 17 says, now this number 17 is molar heat capacity. The quantity of heat required to change the temperature of 1 mole of a substance. Is the answer is molar heat capacity. Molar heat capacity. Thank you. Okay, sorry, I'm trying to get, I'm done with this particular question. I'm trying to get the next one. Okay, so this is the next set of questions we're going to be solving now. So I was taking watermelon. My tummy was biting me. All right. So guys, let's do something now. I think the life is getting longer. Should I solve the remaining parts and drop on the group chat, or I should continue with this live? I want to hear our this thing. Should I solve the remaining ones on chat, or I should continue with the live? I need our views, or should I continue? Or I should just solve it and drop on paper. Or I should just continue. Okay, so Rema said I should continue. All right, now look at this next question that says the number of moles of contained in a sample vial having a volume of 2.20 dm cube if the temperature of the gas is 32 degrees Celsius. Now, first thing first, let's do this. They are asking us to solve for a number of moles. For question number 18, so I put question mark. The volume is 2.20 dm. That is actually PV equals to nRT from the parameters per mole per Kelvin. Okay. Now, the pressure is in ATM, the volume is in dm cube. This one corresponds already. Temperature is in Kelvin. So we're going to, now if you do this, let's press our calculator. 32 plus 273 m. So I'll simply say times 1 ATM is always present in 760 millimeters of mercury. So if you actually divide this by 760, you're going to get the equivalent in ATM. So this becomes my P 750 divided by 760. 750 2 divided by 760. This becomes 0.987 ATM. V equals to nRT. Remember, its V becomes PV all over RT. Now, 7 ATM. Volume is 2.20. Our R is 0.08206 times our temperature is 305. Please press your calculator. Please, permission to eat watermelon. Right? Right, sorry. Okay, let me send this part of the question to the group chat. Favor, why are you vexing? Favor said, why are you vexing? Waiting happen now. Favor, you never reach to vex now. What's the issue, please? Let me send this question on the group chat. Sorry, it's taking time. Ikre favor. Please, I'm waiting. What's the issue? You say you're not happy. So that be your vetting. What's the issue? I can't actually continue this class because I don't like when people when it's fair, she has left. Is let me just complete it. I've already started it. So let me send this to the group chat. My phone is hanging, so I'm sorry. Once it clears up, I'll send it. Let me just continue. I've spent 2 hours already. Oh, my back is aching me bad. So bad. Okay, I've sent the. Okay, so let's continue, class. I have actually sent the question to the group chat. Okay, since network is bad, I will just end the class here. The remaining ones, I will solve it and send to the group chat with full explanation. So let's just send it here. Network is bad if people are complaining. I'll solve the rest and send it to the group chat, all right, before 6 p.m. today. So see you guys by, I'll solve it and share on the group chat, number 18 to 33. If you have any other question, you can actually ask me. All right. At least we've actually achieved something. We've solved from 1 to 17. So the remaining parts, I'll solve it and drop it on the group chat, since a lot of persons are complaining of network, right? So I think that's just the best thing to do. So see you guys. Let's end it live. Let's end it now. So I'll solve it the rest and drop it on the group chat. Okay. So thank you for your time today.